In this problem, it is given that matrix A 2 1 1 2 and also a relation which is P inverse AP is equals to diagonal matrix D1 comma D2. Now let us look into this relation. P inverse AP is nothing but a diagonal matrix. Now if it is a diagonal matrix, then P power n will be always P. Now in this problem, it is given that X and Y are independent variables. Independent random variables. And we have to find expectation of y by x. Now we know that expectation of y by x is nothing but a constant, that is y. So it will be expectation of y. So the answer is option A. In this problem, it is given that y is equals to root over x power 10 plus root over x power 10, so on up to infinite terms. Now we have to find the derivative of this, that is dy by dx. Now there are two ways of solving this problem. One is directly by formula. If y is a function which is root over f of x plus root over f of x plus so on up to infinity, then dy by dx is nothing but differentiation of the function f of x by 2y minus 1, which is d by dx of f of x, which is x power 10 by 2y minus 1. If I differentiate x power 10, it is 10 into x power 9 by 2y minus 1, which is option A. And the other method is take this y root over x power 10 plus root over x power 10 plus so on up to infinity. Consider this entire term as y. Y is equals to root over x power 10 plus y. Now squaring on both sides. After squaring, differentiate them, you will get the answer as A. In this problem, a function f of x comma y is given as 4xy minus x square minus y square. Now we have to check whether it has maximum, minimum, or neither maximum nor minimum. Now, in order to find that, first we need to find fxx, fyy and fxy. Now here fx is nothing but 4y minus 2x and fxx is nothing but minus 2. Similarly, fyy, if I differentiate the function twice with respect to y, it will be minus 2. And fx is always, already we know 4y minus 2x, and fxy, if I differentiate, it will be 4. Now let us take the relation fxx into fyy minus fxy whole square. If this is less than 0, then the function will have saddle point. Now let us substitute the values. Minus 2 into minus 2 minus 4 square, which is always less than 0. So the function has saddle point. So the answer is option A. We have to find the integral of dz by 1 minus z minus 1 whole cube over the curve mod z is equals to 2. That is nothing but a circle whose radius is 2. Now, in order to find this, first we have to find the residues at z is equals to minus 1, as well as we have to find residue at z is equals to 1. Now, residue at z is equals to minus 1 is nothing but 1 by z minus 1 whole cube at z is equals to minus 1, which will give you minus 1 by 8. Similarly, residue at z is equal to 1 will be also 1 by 8. Hence, the required integral is nothing but 2 pi I into summation of residues at pole, whatever the number of poles, which is nothing but 2 pi I into 1 by 8 minus 1 by 8, because they are minus 1 by 8 and plus 1 by 8, which will be equals to 0. So the answer is option A.
If two shafts of the same length and one of which is hollow transmit equal torques and have equal maximum strength, then they should have equal. Here the options are polar moment of inertia, polar modulus of section, diameter and angle of twist. So here, if two shafts of the same length and one of which is hollow means another one is obviously solid shaft, both transmit equal torques and having equal length. So here, and having equal maximum strength also. But we know that here the torque transmitted by the shaft is given by pi by 16 dou d cube if it is a solid shaft, and another one is torque transmitted by hollow shaft is given by pi by 16 dou d power of 4 minus d power of 4 by d. Okay, this is for the hollow shaft and this is for the solid shaft. Here both shafts transmit equal torques, that means Ts is equal to Th. So that is pi by 16 tau d cube is equal to pi by 16 tau d power of 4 minus d power of 4 by d. Okay, and here again pi by 16 by 16 get cancelled, and they are both having equal maximum strength. That means the maximum shear stress induced in the both the shafts is equal. So here both tau in hollow shaft and shear stress induced in the hollow shaft and the shear stress induced in the solid shaft are equal. So that here we get finally, sorry, here just leave the pi by 16 as usual, pi by 16 d cube, and here pi by 16 into d power of 4 minus d power of 4 by d. So here this pi by 16 d cube is nothing but polar modulus of section of the solid shaft, that is Zs. Generally we say that. And here pi by 16 d power of 4 minus d power of 4 by d is nothing but this is the polar modulus of section of the hollow shaft. So that here they should have equal polar modulus of section. So B is the right answer. A 0.2 mm thick tape goes over a frictionless pulley of 25 mm diameter. If modulus of velocity of the material is 100 gigapascal, then the maximum stress induced in the tape is. Here it bends over the frictionless pulley of diameter 25 mm. So here consider it's like a simple bending, then the neutral axis of the beam, the neutral axis of the tape is at a distance of 0.1 mm from either upper fiber, upper extreme fiber or lower extreme fiber, and radius of curvature is equal to, so here radius of curvature is equal to the radius of the frictionless pulley plus y, that is the distance from the neutral axis to the lower extreme fiber. So that here the total radius of curvature r is given by 25 by 2 plus 0.2 by 2, so which is equal to 12.6 mm. So this is the radius of curvature. And coming to the y, and here we will have to find out the maximum stress induced in the tape. So from the equation tau by y is equal to E by R, here we will have to find out the maximum stress induced in the bar, that is E by R into y, where y is the distance from the neutral axis. So here generally maximum stress induced at extreme fibers of the beam. So here also the maximum stress induced at extreme fibers of the tape. So that is from the neutral axis to extreme fiber is equal to y is equal 0.2 by 2. So that is 0.1 mm. And here E is given by 100 gigapascals. So now substitute all the values here, that is 100 into 10 cube Newton per mm square, and y is 0.1 and r is 12.6, which gives a value of 793.6 megapascals. So in the option, the right option is D. D is the right answer. A pressure increase of 200 pascal increases the density of water by 0.1%. The modulus of compressibility of water is equal to, here modulus of compressibility is the ratio of change in pressure to the volumetric strain. So here K is given by del P by volumetric strain. Here the change in pressure is 200 pascal and the change in volume is inversely proportional to the change in water, change in density of the water. So that means here density of water increases by 0.1%. That means the density of volume decreases by 0.1%. So that it is equal to 0.001 and is given by 200 lakhs pascals or 0.2 megapascal. So here the right answer is C. Match the following list with one